Hi, my name is Mark Loftus.
I'm Kate Ruffalo.
And I'm Audrey Brown.
And today we're going to be speaking about Gerhard Herzberg, who won the Nobel Prize in Chemistry in 1971.
He is known for his work in determining the electronic structure and geometry of molecules, especially free radicals.
Gerhard Herzberg was born December 25, 1904 in Hamburg, Germany. He died March 3, 1999 in Ottawa, Ontario, Canada. He won the Nobel Prize for Physics in 1971 on electron structure and free radicals. He received his doctorate of engineering in 1928 at the Darmstadt Institute of Technology. From 1928 to 1930, he conducted postgrad research at the University of Göttingen. In 1930, he was appointed Privatdozent at the Darmstadt Institute of Technology. In the onset of World War II, he fled to Canada in 1935. He was a research professor of physics from 1935 to 1945, and then from 1945 to 1948, he was a professor of spectroscopy at Yerkes Observatory at the University of Chicago.
He then returned to Canada in 1948. While he was there, he was the principal research officer and then the director of the Division of Physics at the National Research Council. In 1969, he was the Distinguished Research Scientist. He was then the president of the Canadian Association of Physics from 1956 to 1957, and finally the president of the Royal Society of Canada in 1966 to 1967.
He found that when molecules react, they are broken down into free radicals for a short period of time. These free radicals are groups of atoms that contain odd numbers of electrons. They then combine to form the products of the reaction. Using the absorption of fixed wavelengths of certain molecules and quantum mechanics, one can determine molecular structure and geometry. His work provided the foundation for molecular spectroscopy, and he also devoted much of his research to diatomic molecules such as hydrogen, oxygen, nitrogen, and carbon monoxide.
Our world consists of atoms that are assembled in molecules. During many chemical reactions, molecules are broken down into smaller parts, free radicals, that are quickly combined with other parts and form new molecules. Herzberg developed these methods, and during the 1950s and 60s, he mapped out the chemical structure of a great many free radicals. To capture the signatures of these free radicals, Herzberg developed high-intensity pulsed spectroscopic techniques to precisely determine the structures and properties of dozens of free radicals.
In 1979, Herzberg published a book with his partner, K.P. Huber. This book was titled Molecular Spectra and Molecular Structure, Constants of Diatomic Molecules. This was a comprehensive reference text with the compilation of all available data known for all of the diatomic molecules and ions known at the time of the publication, which was over 900. This includes electron energies, vibrational and rotational constants, and observed transitions.
In Chapter 7 of General Chemistry, we used his research to predict the shape and structure of molecules instead of having to perform experiments. So we can predict their shapes in addition to using Lewis structures and the Vesper model. Many familiar chemical and biochemical processes depend heavily on the 3D shapes of the molecules and/or the ions involved. So, thanks to Herzberg's discovery, our understanding of molecular structures can be more easily obtained through prediction.
Hi, I'm Ray Schwarting.
I'm Andrew Anderson.
And I'm Logan Ekus.
We are going to be talking about Svante August Arrhenius. He won the Nobel Prize in Chemistry in 1903. Arrhenius is known for his electrolytic theory of dissociation of acids, bases, and salts.
And the famous Arrhenius equation for rate constants in chem equations.
Svante August Arrhenius was born on February 19, 1859 in Sweden. He was a Swedish scientist who studied physics and chemistry. He is known as a founding father of physical chemistry. He won the Nobel Prize in Chemistry in 1903 for his electrolytic theory of dissociation, which states that molecules of acids, bases, and salts dissociate into ions when dissolved in water. This means that he discovered that these ions yield a solution that conducts electricity even when there is no current flowing through the solution. This led naturally to the simple definition of acids and bases, that they are substances that give rise, respectively, to hydrogen and hydroxide ions in an aqueous solution.
Because of the concentrations of hydrogen and hydroxide ions in a solution can be measured, notably determined by the electrical conductivity of the solution, a quantitative measure of the acidity or alkalinity of the solution is provided. The same simple but brilliant way of thinking that inspired his dissociation hypothesis led Arrhenius in 1889 to express the temperature dependence of the rate constants of chemical reactions through what is known as the Arrhenius equation. Arrhenius worked with other famous scientists while researching his hypothesis that later won him the Chemistry Nobel Prize.
His work was focused mainly on the conductivities of electrolytes. In 1884, based on his work, he sent in a 150-page dissertation on electrolytic conductivity to Uppsala University for his doctorate, which did not impress his professors, making him only receive a fourth-class degree. Arrhenius continued to make extensions on this work, which is what led him to receive the Nobel Prize for Chemistry in 1903. In Chapter 16 of General Chemistry, we used his discovery to determine pH of acid-base reactions, which also provided an understanding for the researchers to keep studying electrolytic dissociation, such as Bronsted acids and bases and conjugate acids and bases.
In conclusion, without Svante August Arrhenius and Gerard Herzberg and their Nobel Prize-winning research and discoveries in chemistry, our scientific knowledge in both the classroom as well as the laboratory settings would not be as extensive as it is today. They have helped provide a deeper understanding of the chemical world that allows future scientists to build upon and discover new findings. These are just two of the many scientists that have helped progress what we currently know about chemistry. Who knows what will be discovered next? Thank you for watching.